Claude is no longer just a writing surface, it's a reasoning engine capable of reading large context, can call tools and operate across code. It connects to enterprise systems seamlessly. The real strategic skill isn't crafting prettier prompts, it's designing controlled environments for Claude where it can reason, act, verify, and recover without turning autonomy into operational risk. That shift matters because AI failures now look like product failures. A prompt first team eventually hits a wall. Instructions grow longer and harder to manage. Outputs become inconsistent over time. Every new workflow relies on hidden tribal knowledge. The model is powerful, but the system is fragile. A solution architect asks what must be externalized. Move key logic into durable product architecture. This ensures quality survives new users. It holds up under new data and edge cases. Large context can hold documents, code, policies, and conversation state, but context is just a working window, not a source of truth. Modern Claude models support very large token windows. More input means higher cost, increased latency, and more ambiguity. Architecture starts with deciding what belongs in context, then determine what belongs in retrieval, tools, or storage. Prune everything else to stay focused and efficient. The leap from assistant to solution happens when Claude can safely use tools. Tool use lets Claude make structured calls. These calls are executed by an application or Anthropic hosted tools. This changes the design question entirely. It's no longer about what to ask Claude. Instead, it's about which actions, permissions, schemas, and confirmations matter. What makes the system trustworthy when real money, code, or customer data is involved. A Claude solution has multiple layers. Each layer handles a different type of failure. Intent capture comes first in the stack. Context assembly follows to enrich input. Model routing directs requests to the right tool. Tool orchestration manages complex workflows. Policy enforcement ensures safety and compliance. Evaluation measures output quality. Observability tracks system behavior. Human review adds final oversight. When layers are explicit, teams gain clarity. Reliability improves without rewriting prompts. Blaming models for architecture issues stops. The conversation is just the visible surface. Every tool is a contract between reasoning and execution. The name, description, and input schema matter. Output schema defines what results are expected. Error behavior shapes how failures are handled. Rate limits control usage frequency. Permission boundaries define access scope. Weak tool design leads to silent chaos. Strong tool design narrows the decision space. Constraints become visible and clear. Actions turn into auditable system events. Teams can inspect them after the fact. The model context protocol transforms integrations. It turns one-off glue into a reusable interface layer. No more pasting data from Jira, GitHub, or Figma. Approved systems expose tools and context through a standard protocol. Architects decide which connections get access. They define scope, logging, consent, and isolation. Untrusted content stays separated and secure. Claude Code shows the operating model in developer form. It can read a code base and edit files directly. It runs commands inside the terminal or IDE workflows. This power scales when repositories have clear conventions. Tests, permissions, and review paths are essential too. The architect turns the codebase into a navigable workspace. No more guessing. Automation moves confidently through code. Autonomy without evaluation is just theater. Anthropic's approach begins with clear success criteria. We build evaluations to measure against those criteria. A production Claude system needs golden test cases. It also requires adversarial examples for robustness. Regression checks ensure consistency over time. Tool failure simulations prepare for real-world issues. Latency budgets keep performance within limits. Escalation rules handle unexpected situations. If improvement can't be proven, it's not ready to act alone. No matter how impressive the demo feels, Claude Cost goes beyond just the model price. It includes context size and repeated instructions. Tool loops, retries, and high-end routing add up too. Prompt caching reduces repeated processing and latency. Token counting helps with model routing and budgeting. A solution architect focuses on intelligence per dollar. Maxing out capability per request leads to waste. Waste turns into a scaling tax as systems grow. The mature workflow is simple but unforgiving. Clarify intent before proceeding. Assemble trusted context for accuracy. Choose the right model for the task. Call scope tools with precision. Verify outputs for correctness. Log every decision made. Evaluate results thoroughly. Tighten the system over time. Each loop turns feedback into architecture. Over time, Claude evolves beyond a chatbot. It becomes a governed reasoning layer, continuously shaped by real evidence, thinking like a Claude solution architect.